How's it going, everybody? Welcome to my channel. Today we have a very good problem for you guys. We're talking about basic calculator 2. So this is a very good problem. So make sure you pay close attention to the problem statement. Right? So it says, given a string s which represents an expression, evaluate this. It says to evaluate, right? This expression returns value, right? So the integer division should truncate towards 0, right? So you may assume that the given expression is always valid. All intermediate results will be in the range of -31st to 2 to 31st minus 1, right? So pretty good. You're not allowed to use any built-in function which evaluate strings as mathematical expressions such as eval, right? So they took the fun out the question, so we can't use eval, right? To solve it for us. So what they're saying is pretty much, right, we're given this string and we need to pretty much evaluate the expression, right, and return its value, right? So whatever thing that's represented, right, you see it's 3 plus 2 times 2, right, which the result is 7, right, because it's 3 plus 4, right, because multiplication has higher precedence than addition, right? So that's why we multiply those first, right? Order of operations, right? So we do those first and then we do the addition, right? So 3 plus 4 is 7, right? So same thing here. 3 divided by 2 is 1. Division, 3 divided by 2 is 1.5, right? But it truncates towards 0, right? Divisions, right? So we just remove the decimal, right? We just leave 1 here. And this one we see 3 plus 5 divided by 2, even though those are connected, right? And all you see is space right there, it doesn't matter, right? We need to do the division first, right? After we do the division, then we do the addition, right? So 5 divided by 2 is 2.5, which leaves us with 2, because truncates towards 0. And then we got 3 plus 2 equals 5. That's kind of the answer that we get here, guys, right? So as simple as that, right? So how do we go ahead and solve it? It's kind of the question here, guys, right? How do we go ahead and solve it, right? So the way I'm thinking that we could solve it, right? Maybe it's be better off if we go into the whiteboard, right? And we can kind of brainstorm together. So this is the whiteboard here. So I went ahead and drew. So we'll be doing a stack, right? Stack, or a stack thing, right? Stack-based approach, right? Okay. So let's say stack-based, right? Because what we need to do, right? We need to find a way, right? As we're doing those kind of problems, guys, right? As we're doing this kind of as we're evaluating the expression, right? We need to, if it was only straight up addition, right? 3 plus 2 times 2, no, 3 plus 2 plus 2, right? This would have been simple. We just go ahead and we would just have a running result, right? Res. Every time we would increment it, add the value that it has, right? Res plus 3, res plus 2, res plus 2, right? For each of them, right? It would be very simple. Just straight up go through the, even if we were to add addition as well, right? Let's say we subtraction, right? We wanted to add subtraction, right? We can do 3 plus 2 minus 2, right? So this will be a minus, right? It will be 3 plus 2 is 5, minus 2 is 3, right? This would have been very simple. Okay, very simple here. Okay, but we also have the multiplications, right? And let's say we were to just go straight through, do 3 plus 2 is 5 times 2, right? Gives us 10, right? Which is not the right way of doing it, right? That's not how it is, right? We need to kind of have to worry about the order of operation, guys, right? When a particular operation has a higher precedence than the previous one, right? Things like that, right? We need to account for those kind of cases. So you see, obviously this won't work, guys, right? So we need to be a little bit more clever. And so how about this? How about we go ahead, let's say we were to use a stack, right? So the stack will help us to store intermediate results, guys, as we're evaluating the string, right? So what we're gonna do, right? We're gonna do a couple of stages, right? So in the first stage, we would add the numbers as they are, right, into a stack, right? If they're addition and subtraction, right? But if they're multiplication or division, right, we go ahead and take care of them right away, guys, right? It's kind of the important thing here, right? We take care of them right away because they have higher precedence, right? And they're the top dog, and we could go ahead and just evaluate them right away, right? And there's no other operation that's gonna have higher precedence that's gonna have there's no other precedence. There's no other operation that's gonna have higher precedence than those multiplication and division, right? So we can go ahead and evaluate them right away, right? But if there's subtraction or division, then we're gonna go ahead and add them to the stack, right, to be processed later, right, after we taken care of the VIPs, right, which is the multiplications and division guys, right? So that's kind of what we do here, right? So for this example, we will go ahead and do 3, right? Go into the stack because that's the first one, and then we go ahead, we add 2 to the stack, right? Because that's a plus, right? So we go ahead and add it, and then we see this sign, right? So now we go ahead and process it right away, guys, right? Because and then now this 2, right, is gonna be all right, cool, 2 times, right, the last number, right, which is at the top of the stack that it has access to, right? So it can go ahead and just do 2 times 2, pop it off the stack, right? And go ahead and just change it to a 4, right? And add this instead, right? Which is, result of their multiplication, right? This is what we just had 4, right? So at the end, right, we can just we evaluate all the different at the end we weighted all the characters, right? Then we go ahead and we evaluate the whole string. Then everything that's in the stack, right, we can go ahead and straight up just add them up, right? So this case was pretty simple, very simple actually. So let's say we had this case 3 plus 2, taking on the fly here, minus 1 times 2, right? I think this one is kind of good, right? So the way we would do it, right, we would obviously do this first. This is -2. Then we go ahead and do 3 plus 2 is 5 minus -2. Minus -2 should give us 3, right? Which is the same thing we have 3 here, right? So let's quickly go ahead and run through it, how we would go about it, right? So the algorithm is going to be very simple. So we would just do 3 because it's only a number. Then we go ahead and do 2, right? Then we go ahead and do -1, right? Because if there's subtraction or addition, we just add them straight up, right? And we see a 2 here. 2 is a multiplication, right? And that's kind of what it's pointing at, right? So it's multiplication. So what I'm going to do, I'm going to pop whatever's up the stack, right? And then add our result instead, right? Because that's what we're equal to, right? So this is what we're going to add instead in the stack instead of those the one itself, right? So we're going to change this to a -2, right? And at the end, what we do, we just go ahead straight up 3 plus 2, right? 5 minus 2 gives us 3, guys, right? So it's as simple as that, right? The gist of this problem is that we do the multiplications and divisions first, right? And then at the end, right, we process the additions and the subtractions that needs to be done, right? So as we're going through, we're going to need to keep track of a couple things, right? We're going to need to keep track of the current number that we're building, right? And also we're going to need to keep track of the sign as well that we are on, right? So we can know whether to do the evaluation right away or wait, right? So that's kind of what I'm doing. What we're going to be doing, we're going to keep track of that. And yeah, I think that's the gist of it, right? And then we're going to make sure that we ignore any white spaces that don't matter, right? So let's quickly go into the code. Hopefully it makes more sense and more sense when I go through the code with you guys. Okay, so let's quickly go into it. Guys, let's quickly get into the code. It'll be very simple. So like we said, we're gonna use a stack data structure to keep track of the intermediate results. All right. So stack, go ahead and use stack, right? Okay, once we have that, we're also going to need to keep track of a couple of things, right? The current number that we are building, that we have, and the operation, right, that we have as well, that we're considering, right? So that this will help us in letting us know what to do, right? Once we, once we encounter a division or subtraction, right? It's going to allow us to make decisions, right? So that's why we need to keep track of it, right? So we're going to have a for loop, right? So we're going to process things character by character, guys, right? Process the string character by character. Okay. Okay, so we're just looping through the string, right? And then we're going to extract that string, that character, right? From string. With this current iteration, or so we capture right there, right? So for that character, right, we're gonna do a check, right? If it's a digit, right? So that's what we can have, right? If this character is a digit. it's a digit. Then we're going to build our current number that we have, right? So current num times 10 plus the ASCII value, right? Subtraction from 0, right? So this is a very common way of doing of converting like a string, number string into an integer, right? By doing this technique, right? We multiply times 10, right? And then so initially it would be 0, right? Times 10, right? Which just gives you 0, right? For 3, right? And then we would subtract the ASCII value of 3, right? Of this guy with the ASCII value of 0, right? That difference is the integer value, right? That it represents, right? So 3, right? ASCII value of 3, whatever that is, right? Versus, what I'm saying, like whatever the ASCII value of 0 is, right? We subtract them, we get the actual number, guys, right? That's kind of what it is, okay? So instead, this is like, I don't know, 10, and this is 13, right? The subtraction gives us 3, and then we can build it like that, right? And then if it was like 30, right? We had like this 30 case, then the next iteration, right? It would keep building it, right? So it would do 3 times 10 to shift 3 to the left, right? And then plus the 0, right? Which is ASCII value of 0 minus the ASCII value of 0, right? Use just 0, right? So hopefully it makes sense to you guys. We've done this multiple times in other problems as well. So, so now let's say, we in the end of the case where it's a digit, right? We build a number, okay, everything was good so far. So what's next for us, right? Is to check, right? There's other cases where when we are dealing with a non-digit, right? So if the character is not a digit, okay, and also make sure that this character also is not an empty string, because we're not worried about empty strings here, guys, right? So we would simply, if it's not empty string as well, right? So if it's not a digit and it's not empty string, it must be those operators, right? So we need to make decisions now, right? So if, for example, all right, so we get to here, right? We need to put our number into the stack, guys, right? So we're gonna do a check here. If the operator, right, is a plus sign, then we go ahead and push it onto the stack. Okay, push the current num that I had, right? Then build it. I built, right? So I got 3, and I counter non-digits here, and then I push whatever number it was, right? So initially we started off with a positive, with like plus sign, right? So we just go ahead and push it, right? And then we have this other case as well, right? So now we need to worry about, if it's a negative, right? If it's a negative, then we go ahead and just push it to the stack, right? Because we're not going to prioritize them now, right? We're just going to go ahead and push them there, right? So, but if we get those other cases where we have a positive or we have a negative, right? Then we're going to need to be a little bit more clever, right? So let's do the addition case, right? So what I told you, whatever number that is at the top of the stack, right? We just grab it there, right? Stop that pop, right? So we get that number, and then we're going to multiply it with current num, right? Multiply, and then we do the same thing here, guys, with division. The only thing that changes is the division, right? That's it. So we store the, if it's a positive, if it's a addition, we just add them to the stack, subtraction, add them to the stack, right? As is, right? And then if it's a multiplication or division, right, we go ahead and process them here, guys, right? So let's go so far. So now that we've operated, right, we process that, right? So we're gonna need to reset current number, right? So current number has already been taken care of, right? So now the next time it encounters a new number, right, it needs to start off fresh, right? Because if we don't have that, it's gonna mess up the calculation here, guys, right? So to start off fresh, so we reset our current number to 0. But also we need to capture, right? Since this is a non-digit, and it's also not a empty space, right? We need to it's an operator, right? So we need to capture that operator so that we know what to do once we start building the next number, right? So for this example, we see multiplication, right? We store it here, right? And then, right, once we go ahead and current num, we build a digit. Then, so now we see we need to handle the last case where the last index is a number, right? And there's like, it's not it's a digit, right? So we need to account for that, right? So if it's also the last, right? So we're also going to evaluate the expression also if it's the last index in the string, guys, right? So it's a very important case that you guys need to take care of as well. Okay. Let me zoom out a little bit so you guys can see it, right? So if it's the last one, we're also going to try to evaluate it as well, right? So that we get into this and we can do the operation, right? Either to push it to the stack or do the operation right away, right? And after we are done with doing all of this, guys, right? We capture the operator, right? Before we start processing every number, right? So that we can make decisions, right? And then what's next for us to do? We've processed the whole thing, right? Going through the string. Is just to start building our upper result, right? So we do n equals 0. And then we loop through everything that's in the the stack guide, right? Stack. So we do res plus equals to num, right? So it will add up all the numbers in there, right? All the subtractions, right? Everything in there. And then we return the result, right? So we prioritize all the multiplication and divisions, right? We process them right away, right? And they were good. So hopefully it makes sense to you guys. Press submit. So the test case that I added didn't make sense because it says negative numbers. Cool. Press submit. Awesome, guys. We're gonna pass all the test cases, guys. If you guys found value, guys, in this thought process, in the comment section. If you guys are new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.